Jai Shriman Narayan kids. We'll discuss the JEE Mains 21st January, the evening of the second shift. JEE Mains 2026, 21st January, the second shift. The physics is easy as usual, and the chemistry also came easy, and the maths is moderate. I think there's a after a long gap we are having the maths which is come under category of moderate. So the overall paper, we can call it to be moderate paper. Fine. Then what actually happens, you check it. For 92 percentile, you have to get 115 marks. Because the paper has become category under moderate. huh? So to get 92 percentile, 115 marks, you have to solve more questions here. 94 percentile, 130 marks. 96 percentile, 150 marks. 97 percentile, it is around 173 marks. The threshold, 190 marks for 98 percentile. This is something huge burden for all of you. Those who have scored easily from every subject, what will happen? You are supposed to score minimum 15 questions. Then only what happen, that particular threshold you will reach here. Okay, fine. 98 percentile. So those who are having around 190, may not be, it may come to 185 or it may go up to 196 also. For 98 percentile, so your total should be around 190 plus or minus 5 marks we can add up. The paper seems easy, no? So definitely what will happen, to score the even 98 percentile, you have to go for the high level. Morning shift, it was around 140. 50 marks variation. Yes, it will come due to the this was moderate and this was tough, no? The difference it will make it. Okay, fine. Next we'll go for the physics weightage. Let me increase the volume button. Okay, now the physics weightage. The physics weightage one. Mechanics, he has gone for 10 questions. The mechanics 10, LCT maximum 6, including EM waves here. Modern physics 2, optics 3, wave motion 1, thermal physics 2, experimental physics 1. And this is our typical weightage, which usually we see in the physics 1. Again, if you check the number of questions from the class 12, LCT maximum, modern physics, wave motion, optics. So I think if you check this one, 9, 10, 12 questions came, and 13 from the first year physics. Okay, fine. This is the preparation. Then the type of questions. Sir, what do you mean by this type of question? Type of questions means, like, again in the physics we have numerical based almost in all subjects. There 5 questions will be there where formulas are needed. Based on the formulas only we are able to solve. This is very important. That's why I'm just stressing this aspect also. Next, objective type formulas means, like, here we used to end up some value. Here it can be anything. It can be in decimal or of any time, any kind. And total together 15 questions means definitely your physics preparation is all about formulas. If you are very sure about the formulas and concepts, 15 questions are manageable. And very strange, this particular paper, objective type 9 derivations means a situation is given where you have to solve. You will get an equation, the answer. and options will be there. Like there 9 asked. This is in spite of that, paper is easy. Maybe it's our simple derivations. There's no anything called like a conceptual assertion reason one, and there's no any matching. So once again, this is something which is stressed more. Usually this will be 4 or 5. Hmm? So and this should be more, but he has gone for 15 questions only formula based, simple formula based too. So those are all writing the shifts like a 22, 23, 24, 28. This is your major strength. Every chapter, improve the formulas, revise the formulas, recollect the concepts. Just only formulas, huh? With that you can manage this section. Hmm? This will be routine for all 98 percentile to the top 100 percentile. This is the thing which will decide your the best performance. So revise all formulas. Don't bother now solving PYQs. Now there's not a time. It's a time to recollect all the formulas. Okay, fine, kids. Huh? So overall paper easy. So we'll enter into the paper solving. Huh? I'll explain all the through concepts, all what are the ideas involved, everything. Huh? So let me start with the paper solving. I'll take out this camera because I'll not be in a position to view camera and solve it. I'll keep it here, but I'll be solving let me try few questions if I can do it with camera. Okay, now the first question, in the given LC circuit, charge on the capacitor is maximum at t equals 0. Find the time at which charge becomes 25% of its initial value for the first time. This is something problem related to LC oscillations. Problem related to LC oscillations. Now, what we have to do like LC oscillation. So what is the expression for this one? Q is equal to, I'll bring like Q equal to Q naught cos omega, because at t equals 0 the capacitor is charged. Then okay, now what we do is like find the time at which charge becomes 25% of it. 25% means will become Q naught by 4 Q naught cos omega t. So this will become 1 by 4. So 1 by 4 cos omega t. So t equal to 1 by omega cos inverse of 1 by 4. What is omega? 1 by root LC. So this will become root LC cos inverse of 1 by 4. And this is problem based on electromagnetic induction, subtopic LC oscillations. Very rare they've asked. I'm a bit surprised. Okay, fine. They've asked. Again, possibility of asking very less. And this will come under category of easy. I'll take the next one. This is based on the kinematics. Subtopic relative motion. Two cars moving parallel to each other with velocities as shown. Initial separation between the cars is r equal 10 meter. Find the angular momentum of car A with respect to car B. Okay, he has gone from here kinematics and rotational motion. Find the angular momentum of car A with respect to car B. How to find out this angular momentum? We'll calculate the velocity of this. So velocity of car A with respect to B. BA minus VB. This will be 36 minus 72 into 5 by 18. 36. Altogether, the difference, velocity of car A with respect to car B, or car B with respect to car B with respect to car A, will write it. Some small correction I'll make it. Car A with respect to car B. Okay, I think I'm right. I am right. Now this will become 36 into 5, 18, 10. Then angular momentum of A with respect to B is equal to mass of the M2 VAB into R. M2 is how much? 3 by 2M. VAB is 10. R is also 10. 150 M. Car A, mass of car A will be M, no? Mass of car A is M. M only will substitute this one. So this will become 100 M. Something rotational motion, including with relative motion, is applied it. We'll take the next one. Work done in an isobaric process is 100 joule. If adiabatic constant for gamma is, find the heat given to the gas. What is the basic formula in adiabatic process? Okay, this is based on thermal physics, thermodynamics. This category will be easy. Q equal to delta U plus W. We know work done. Work done, this we can write it as NR delta T gamma minus 1 W. The delta U. NR delta T, work done is NR delta T. So work done by gamma minus 1 W. Gamma by gamma minus 1 W. What is the gamma? 1.4. 1.4 minus 1 into work done into 100. 14 by 4 into 100. 700 by 2 will be 350. Question based on current density, series parallel. This will come under category of easy. For the given resistive network, the net resistance across AB equal to X, then find the value of X. I think it's based on the series parallel only. So what is the resistance? X is equal to R plus 2R into X, 2R plus X. X is equal to This will be 2r square plus rx 2rx by 2r plus x 2rx plus x square 2r square plus 3rx. So this will become x square minus 2r square minus rx equal to 0. Quadratic equation. Solving for x will get this option. Quadratic equation, it will come 2 plus or minus 4 4r by 1. A simple one. Next again, this question, consider two statements assertion in YDSC. The distance between slits and the screen increases, fringe width also increases. If the wavelength of light used increases, fringe width also increases. This question based on YDSC. Wave optics. A easy one, huh? This will be an easy one. Then, what about if the distance between slit and the screen increases? Fringe width. Expression for fringe width, lambda capital D by small d. If the distance between slits and the screen increases, fringe width also increases. Correct statement. W increases. If the wavelength of light used in Y increases, fringe width also increases. Fringe width increases if lambda increases. Both the statements are correct. Next, we are having the experimental physics. Experimental physics based on the errors. Two physical quantities x and y as measured values 23 and 373. The value of x plus y. Now what we have to do when you are adding up, you have to 23.01 37.3. You have to go for the least decimal places, no? 1 3 0 6. What are the least decimal places? in the quantities which you are adding least decimal places. So here 1 is there. So this has to be rounded off. So this will become 60.3. And this is less than 5. So the preceding should be as this is less than 5. So what will happen is the preceding should be left unchanged. So 60.3 will come. So this will be your option. Next one is find the magnetic field at point 2 in the given figure shown. What is this? There's a long wire, infinitely long current carrying wire, and we are having this a ring, current carrying ring. We have to calculate the magnetic field at the center. How much magnetic field at this one? So this particular problem is based on the Biot-Savart law, moving charges and magnetism. This will come under category of easier. We'll make it here. Now, due to the wire mu naught I 2 pi r out of the plane. Due to the ring, mu naught I to R into the plane. So you take mu naught I to R outside, 1 minus 1 by pi. This one due to wire, this one due to ring. Next we are having the charge and potential applied across a particle R. For a charged particle, a potential difference is applied. Find the de Broglie wavelength of the charged particle. What is the formula for de Broglie wavelength? Lambda equal to h by mv, where mv is the momentum, and this should be equal to 2mk, and k should be equal to charge into potential difference V naught. So substituting all this, h by 2 m q into V naught. Some data is needed. Here given charge is given mass. Potential also should be given. Some potential also I'm missing it. Let me recollect somewhere. De Broglie matter waves question. Some potential difference of 1.21 volt. Mass is 6.4 into 10 to the power of minus 27 kg, and charge is 3.2 into 10 to the power of minus 19 coulomb. Substitute all this, solve it. It's a numerical type. It's a numerical type. Will end up something like a value is an integer type. H value also given 6.6 into 10 to the power of minus 23 joule second milli. That one. Okay, fine. It's all about calculations here to work out. This based on the matter waves. Problem based on the current density concept, maximum power transfer theorem. Let me read the question. In a circuit, there is a battery with internal resistance small r and EMF E, which is connected to external load resistance R. This one. Find the value of R so that maximum power dissipates across the R. What is the condition for the maximum power dissipated? If the internal resistance of the cell equal to the load resistance, that I think this was derived. I'll go for directly this. There's a condition, no? When the load resistance is equal to internal resistance, then the power transferred will be maximum. Okay, fine. Huh? Next one, refractive index of the prism. There's a prism is not there. I'll bring the prism also. Yeah, fine. This question based on the ray optics. Huh? There's a right angle prism, angle 45 degrees, given like this, such that the emerging ray grazes out of the surface. It's asking to calculate the angle of incidence. I think if you can recollect concept, huh? This is the incident ray. This is a normal. Now what he's asking is find this angle of incidence so that the emergent ray grazes out of the surface. So here the ray will undergo refraction. I'll show by other color. See it. Then finally it should emerge out grazing other surface. For this, what is the basic condition? I think the angle of incidence should be equal to how much? Should be 90 degrees. So we'll do one thing. We will start like this. This will be R1. This will be R2. This will be 90 degrees. Again, from here, this is a right angle triangle, right angle prism. The diagram is given. So from this, what we can write here? R1 plus R2 is equal to 90 degrees. Then R2 should be equal to critical angle. Then only grazing emergence is possible. Okay, I'll try to explain. This is the incident ray. Then undergo refraction. It should graze this surface. This will happen only when this angle is equal to critical angle. And this angle should be 90 degrees. So R1 plus R2 should be equal to 90. And R2 is equal to critical angle. So we'll substitute all the values now. So this will be R2 plus critical angle 90. R1. R1 equal to 90 minus C. So sin I equal to mu sin I. Cos C. So what is the maximum so that the emergent ray grazes out? What should be the angle of incidence for a light ray? Okay, there's a grazes out. We are theta 90. I'll do it some. I'll start from here. There should be like a mu sin R2 1 into sin 90 degrees root 2 sin R2 into 1 into 1. R2 will be 45 degrees. If R2 is 45 degrees, R1 will be 45 degrees. If R1 is 45 degrees, sin I 1 into, here will apply it. Snell's law of refraction. Okay, fine. 1 into sin I. This should become equal to mu into sin R1. Sin I mu is root 2. 1 by root 2. Sin I equal to 1. I equal to 90 degrees. Okay, fine. This is based on the ray optics, prism concept. This problem based on the circular motion, centrifugal force. A block of mass m is attached with respect to hollow cylinder which is rotating with angular speed omega about its axis of radius r. Find the minimum coefficient of friction between the block and the cylinder. The condition is put it. So what are the forces that will be acting? The forces that will be acting are weight mg, normal contact, centrifugal force mr square, and there is a friction. Then for equilibrium, with respect to cylinder will be attached, no? So F equal to mg, mu n equal to mg, then n is equal to m omega square r, mu m omega square r equal to mg. So mu is equal to g by omega square r. Now simple, I think almost all students might have come across this particular problem. Very easy one. This based on again current density. Meter bridge. In a meter bridge, two balancing resistance are 30 ohm and 20 ohm. If galvanometer shows zero deflection for the jockey's contact point P, find the length AP. Usually meter bridge length, how much will be there? This length will be 1 meter, 100 centimeter. This is very important. And the galvanometer will show zero deflection. So this is something problem based on Beeston network or the meter bridge concept. Galvanometer 30 ohm, 20 ohm. Then this will be resistance R1, R2. No deflection. Then 30 by 20 equal to R1 by R2. 30 by 20 is equal to R1. R1 will be lambda into L. R2 will be lambda into 100 minus L. Then what about this length? This length will be 100 minus L. Then what is the resistance? Lambda into that one. It's asking the balancing length. I think this will become now 100 minus L equal to 2L by 3. 5L by 3. Balancing length will become 60 centimeter. We'll take the next one. Two spheres having equal mass, charge q, and radius are moving towards each other. Both have speed u at an instant when the distance between their centers is 4r. Minimum value of u so that they touch each other. Something this question is based on. What is the name of chapter? Electrostatics. From electrostatics we have to minimum distance is asking. Minimum value of so that they just touch each other. Finally, they will come in contact. These are the sphere, this other one. Both will come in just in contact. Each will have radius r and they'll come to rest. This is sphere A, this is sphere B. Why do they come to rest? Because of repulsive force. An electrostatic repulsive force here, because there's a charge Q and Q is there. Because of that charge, a repulsive force will be acting in the direction. This repulsive force, what it will do, will make it to retard. Will make it to retard. So finally, they just come to instantaneous rest. They're having charge. Sir, what about the charge? Can you show the charge? Yes, charge will be there here. No, nothing will happen to the charge here. Now we'll apply the conservation of mechanical energy. They'll undergo retardation. Everything I'll show here only, and because of that, the velocity decreases. So initial kinetic energy, applying conservation of mechanical. This based on electrostatics. Applying conservation of initial kinetic energy 2m u square by 2 plus interaction potential energy k q square 4r, and finally kq square 2r. Why kq square 2r? What the separation finally between the centers will be 2r, no? What was the initial separation? It was 4r. Okay, this will become mu square kq square 4r u is equal to kq square 4mr. 16 k equal to 1 by 4 pi epsilon naught. Easily manageable electrostatics based on the conservation of mechanical energy. Next, we'll go for directly thermal physics, KTG. RMS speed of hydrogen and oxygen are same. If the temperature of oxygen is gas 20, find the temperature of hydrogen gas. What is the formula for RMS speed? Three RT by M naught. And both the speeds are equal. So therefore, what we can write here now? T1 by M1. M1, M2 will go for like this. And this is T2 equal to T2 by M2. So this will become T1 M1, T2 M2, M1 by M2 into T2. Molecular mass of hydrogen 2. That of oxygen, this one. Temperatures is asking, this is in 300 Kelvin, 23 degrees Celsius, 300 Kelvin. Then we'll get in Kelvin. 23 is there, 273, okay, 296. This there, so answer will get in Kelvin. 18.5 Kelvin. Easy one. There's a based on semiconductors, modern physics, semiconductors. Easy one here. Now let's read the question. For the given circuit arrangement, find the charge on the capacitor in steady state. It's asking to calculate the charge on capacitor with the diodes. Now which diode will be forward biased? This is p-type, n-type. This diode will be forward biased. This will be N9P. This will be reverse biased. Forward bias means short circuit. Reverse bias means open circuit. The overall circuit will be now forward bias, 3 ohm, 3 ohm, 2 ohms, 1 ohm, 2.5 volt. We have to calculate this drop. Find the charge on capacitor at steady state. At steady state, again, this will be open circuit. Only the current, where do it will flow? Current will flow only in this path. I. So what is the expression for I? 2.5 plus 1 plus 3. 5 by 2, 4. 5 by 8 ampere. Then no current flows across this resistor. No current here. Why? Because capacitor will be open circuit. Now we'll write AB. So VA, current will enter. VA minus 3I minus VB 0. VAB equal to 3I. 3 into 5 by 8 will be 15 by 8 coulombs. Sorry, volt. So what the charge will be? Steady state charge will become Q equal to C into VAB. 5 micro into 15 by 8. 75. This will be your answer. So very good question. Where is bringing capacitor? A capacitor and also diodes are there. Very good question. This question based on the atomic physics. Atoms, modern physics, easy one. An electron in a hydrogen-like atom has energy equal to 0.04 E naught, where E naught is magnitude of energy of this electron in the ground state. If angular momentum of this electron is L, then the value of 2 pi L H. So what is the question? Question is based on the now regarding the angular momentum. Now in general, E naught is magnitude of this electron in the ground state. In the ground state, how much of energy it will have? 13.6 electron volt. Z square. Then some level, we'll write it here, 13.6 electron volt Z square by N square equal to minus 0.04 E naught. Solving this, we'll get N is equal to 5. Then what is the angular momentum? 2 pi. Angular momentum, this electron is L, then the value of angular momentum. Angular momentum, what is the formula? NH by 2 pi. NH by 2 pi. Now we'll adjust everything. 2 pi L H. Value of this is asking. 2 pi LH should be equal to N. So this everything will become equal to 5. Something this data very important. Next, I have to go to college. I'll hurry up. Let me speed up this one. This question is based on oscillations. During SHM, kinetic energy of particle varies with frequency of. Find out the frequency of SHM of the particle. Directly, if x equal to a sine omega t, velocity equal to a cos omega t, kinetic energy equal to half mv square, a square omega square m cos square omega t, m omega square a square by 4, 1 plus cos 2 omega t. If omega is the frequency of the particle, of vibrating particle, what will be the frequency of the kinetic energy variation? It will be twice. So in general we write like this, no? Frequency of particle will be half of the frequency of kinetic energy variation or kinetic energy or potential energy variation. Or the find out frequency is how much? 176 by 2. This will become 88. Based on oscillations. So what is the concept? If f is the frequency of the particle, then 2f will be the frequency of kinetic energy variation or potential energy variation. This is about the work energy power. What he has given? He has given the position x of the particle of mass 2 kg varies as a function of x. Find out the work done on the particle 2 to 3 seconds. What we have to do? We have to calculate the many methods are there. First, let me what is given? X equal to t square t plus 1. Velocity equal to 2t plus 1. Then is asking work done at 1 second at equal to 2 seconds. It equal to 2 seconds. 2 into 2 plus 1, 5. At equal to 3 seconds. 2 into 3 plus 1, 7. Work done equal to mv3 square by 2 minus mv2 square by 2. 2 get cancelled, v3 square, 7 square minus 5 square. 49 minus 25. 24 joule. Let me take the next one. Problem based on the viscosity. A spherical ball moving with terminal velocity, radius of the ball is, he's comparing two balls. Having radius r1. What is the formula for this terminal velocity concept? To like a terminal velocity formula. 2gr square 9 eta density of the ball minus density of the liquid. So therefore v1 by r1 square equal to v2 by r2 square. I think you can easily solve. Find the terminal velocity. V2 is what is asking. V1 is how much? 20 centimeter per second. V2 is asking. R1 is 6 millimeter. R2 is 3 millimeter. Will come 4. Now there's some good question is there. In the diagram given below, pulleys, ring of mass m and radius are fitted with 2 rods, each of mass m and length 2r. Here. These are the 2 rods. So that it pulley rotate. Rods also rotate with same angular velocity. Find the magnitude of acceleration of m when the system is released. So something is related to rotational motion. Concept of rotational motion, we have to apply it. Weight mg. Here I'll write m naught. Then it will also rotate alpha. They will have acceleration here downward. This will be upward. Let T be the tension. Okay, we'll write down the equation. This will move down. This will move. Mg minus T equal to Ma. Tensions will be different. Why different? Because pulley is having mass. Okay, then T2 minus Mg equal to M naught. Okay, then torque will act like this. Alpha. Then A equal to R alpha. There's one more condition. Let A equal to R alpha. The acceleration of this point and the block will be equal because of constraint. Similarly, acceleration of this point and the block will be equal because of constraint motion, because of the string constraint. Tangential acceleration of this point should be equal to acceleration of this block because the string will provide that constraint motion. Similarly, the tangential acceleration of this point should be equal to acceleration of block because of this vertical taut string. Then this whole, it is rotating with an angular acceleration alpha. So therefore A equal to R alpha. Then T1R minus T2R. There are 2 rods are there. If you make observation, 2 rods are there. One rod like this, one rod, and they're rotating about the center, about an axis passing through center and perpendicular to plane of the rod. So what is the moment of inertia? Length of the rods are 2r, like diameter. So we'll write here now. M into 2r whole square by 2l into 2. Why 2? Because 2 rods are there into alpha. So T1 minus T2. 1 r will cancel out. Here 4 will come. Here 3. So this will become 2mr alpha by 3. T1 minus T2. A equal to r alpha. So this will become 2ma by 3. Substitute all the values, we can calculate the acceleration. T1 will be from here. T1 equal to mg minus ma. T2 will be capital M. These are capital M. Little bit careful. My handwriting not correct. T2 will be small 2ma by 3. These are small m only. Let me go for it. Again, you'll get confused. Okay, fine. This we have to solve it. We'll get the option 1. And this is based on rotation motion. Torque equal to I alpha concept. Now there's a river boat. Kinematics. A boat crosses river 200 wide in minimum possible time, shortest time. Velocity of river given. Velocity of boat in still water means velocity of boat with respect to river only. Find the time taken to cross the river and displacement of the boat. I think this whole thing is about the boatman. You will cross the river in shortest time. So how the velocity of the boat with respect to river like this? How the velocity of river? Velocity of river will be in this direction. Then this will become VR. Velocity of boat with respect to ground like this, and this is a displacement, and this is a W. Time taken equal to W by VBR. Okay, and this is theta. From tan theta, we can write it as VR by VBR x by W. So x equal to W by VR by VBR. Substitute all the values. Wide means this is a W. This is VR. This VBR. Okay, everyone, can you do calculation? Let me take the next question. This based on wave optics or YDAC. In YDAC experiment, central magma shifts by 20 millimeter in slab of thickness 20 micrometer and refractive index mu. The distance between find alpha is asking. What is the formula here? This will become S2. Here the incident rays lambda. There's a distance. This will be S1. Let this be P. This is capital D and this is Y. Then formula will be delta X equal to S2P minus S1P dash. I'm just showing the method. S2P. This will become S1P minus T plus mu T. Okay, sir, something you are writing like this. What is the meaning of that one? This wave will cover a path S2P. I'll show this. Wave 2 will cover a path S2P. What about wave 1? Wave 1 will cover a path S1P minus T in air. Then it will cover a path T in slab. So optical path and mu T. So this will become S2P minus S1P minus of mu minus 1T. This is due to geometry. This is due to slab. We're asking n lambda. So YCM is equal to mu minus 1 T by capital D small d. This is the shift due to slab. Substitute all the values. We'll get some numerical value. We'll get 8. This is about the next question is based on the EM waves. Let me read the question. A medium having conductivity 10 Siemens per meter, electromagnetic waves of frequency 100 megahertz are passed through this medium. Find the ratio of maximum displacement current and conduction current. Okay, something very good question is there. Huh? EM wave of frequency. Displacement, conduction current is okay. Okay, this one. Conductivity Siemens. Huh? There's a conductivity definition of Siemens per meter. Reciprocal of resistivity is what we'll call that one. Siemens that one. So don't get confused with this. First, we'll start with the conduction current. Conduction current usually we'll write J equal to sigma E and IA. So this will become sigma A into E. And it's a EM wave. Sigma A E naught sine of omega t minus kx. Relative, this he has given a relative permittivity. Find the ratio of maximum displacement current, conduction current. Maximum values here. What about the displacement current? Displacement current, this is electric field vector. Displacement current will be id equal to epsilon naught epsilon r dE by dt. Hope you remember there's a formula. Why this A will be there? Into area. Okay, this one. This will become epsilon naught epsilon r E naught omega. We have to differentiate this. E is equal to how much? E naught sine omega t minus kx. Omega cos omega t kx. Maximum value of this is equal to epsilon r E E naught omega. Maximum value of this. Sigma A E naught. Asking find the ratio of maximum displacement current. ID max by I conductor max. Epsilon r A E naught omega sigma A E naught. So this will become epsilon r omega by sigma. Then we'll get 3 900. Epsilon is the relative permittivity. Omega frequency, waves of frequency. He has given 100. Frequency given 100 megahertz. And conductivity, sigma, he has given 10. A little bit very odd problem. Problem based on EM waves. Next, there is a two capillaries are dipped in two different liquids having meniscus R1, R2 and sufficient T1 if density of liquids are same. Is asking some relationship. What the formula for sufficiency formula? To sufficiency T will write symbol by cos theta rho g r. There's a formula for surface tension. Next is asking the comparison only here. Now we can compare here now. R1 greater than R2. T1 equal T2. Okay, fine. This option will come directly from here. And this theta will not be there. This is the radius of meniscus. Or if you want, in terms of radius of the tube, it will be 2t cos theta by rho gr. There's a basic thing. He has given the radius of meniscus, so we have to use this formula and this will come. And this problem based on surface tension. Let me see. Okay, this one. Next, last one. Figure shows a ball falling in viscous medium with quotient of viscosity theta. If error in the measurement of radius, terminal velocity, density of ball is exactly known, the fractional measurement of quotient of viscosity. What is the formula for quotient of viscosity? And this one, terminal velocity is equal to 2g r square 9 eta by density of the ball minus density of liquid. dv by v, terminal velocity, plus or minus equal to 2 dr by r plus or minus d eta by eta. Then this will become dv naught by v naught minus of plus or minus d eta. Okay, sorry. This will be 2 dr by r d eta by eta. Now minus of this will be again, always we have to go for additive. We should always go for additive. And we should not go for subtraction. This will be wrong thing, because always we have to search for maximum possible error. Okay, this when they are additive, maximum possible error will come. So what is the why we should not consider negative sign, sir? Why you are not considering this negative sign? Errors must be additive for maximum possible error. The relative error must be additive. I think this already I discussed. Okay, fine. This will end up your session 2, 21st. So all writing the session like a 22nd paper, 23 paper, 24 paper, 28 paper for both the sessions. All the best from your Sridhar Sir. All the best. Again on 22nd afternoon, we'll going to discuss the paper 1, shift 1, and in the night, the shift 2. Okay, thank you for all your cooperation. Thanks, all the best.